Today I'm going to show you one numerical mathematical problem based on application of ideal gas law. So this problems belongs to chemical process calculation or stoichiometric calculation. Now here is the problem statement. Calculate the volume occupied by 40 pound of nitrogen at a pressure of 750 mmHg and 80 degree Fahrenheit. So now here I'm going to solve this problem, and that target is calculate the volume. So we have to calculate the volume. So before that, so first step 1 is convert mass to mole. So now here that mass of nitrogen is 40 pound. Now we know 1 pound is equal to 453.592 gram, and total mass of nitrogen is 40 pound. Now if we convert mass into mole, so that is 40 pound into 453.592 gram per pound, means 1 pound is exactly equal to 453.592 gram, and molecular mass of nitrogen is 28.02 gram per mole, means 1 mole of nitrogen contain 28.02 gram. So now if we do that and if we calculate, so number of moles will be 647.77 mole. So that we got step number 1. Second, convert 750 mmHg to atmospheric pressure, and we know 1 atm is equal to 750 mmHg, 760, not 750, 760 mmHg. Now here 750 mmHg to atmospheric means 750 by 760, so that will be 0.9868 atm. Now convert 80 degree Fahrenheit to Kelvin, so we can convert Celsius and then we can convert Kelvin. So here 80 degree, so here we know that F minus 32 by 9 is equal to C by 5. Okay, so that way we can do that. F minus 32 by 9 C by 5. C by 5 is equal to F minus 32 by 9. So using that, so we can easily calculate what will be the Kelvin. So TK is 299.82, and we know T degree centigrade plus 273, that is in Kelvin. So temperature in Kelvin 299.82. Now using the formula PV is equal to nRT. So P we know, we already calculated 0.9868 atm. V we have to calculate. T 299.82 Kelvin. N we know, already we calculated, that is 647.77 mole. Now we need R. So here we must remember, based on the atm, Kelvin and mole, we can use that R. So here R is 0.0821 liter atm mole Kelvin. So now if we put all these things, so here that V is equal to 647.77 into 0.80821 and then T 299.82 divided by P 0.9868. So ultimately we will get that volume is 16181.62 liter. Now we know 1 liter is equal to this feet cube, so V will be multiplied with that factor. So V we got, so that is 161 161 and 16181.62 liter. So if we convert that, so 1 liter is equal to this much of feet cube. So from that we can get the volume is 571.26 feet cube. Now in this problem we remembered R value. Without R we can't do the calculation. Now here I'm solving another way. So here that is the conclusion is 40 pound of nitrogen at 750 mmHg and 80 degree Fahrenheit occupies approximately 571.26 feet cube. Now if you remember at STP, so first we have to derive R and then we can do the calculation. So first we have to remember this statement. At STP means 273.15 Kelvin and 760 mmHg, 1 mole of an ideal gas occupies 22.414 liter. And from here, so we can use that PV is equal to NT and we can find out R. So R is equal to PV by NT. Now P is equal to 760 mmHg into V is equal to 22.414 L and 1 mole into 273.15 Kelvin. So if we do that, so liter mmHg mole Kelvin, so we get R value. Just we remember at STP 1 mole of ideal gas occupies 22.414 liter, and from that we can easily calculate what is the R value. Now after getting R, now again we have to convert mass to mole, so that we already did that in earlier slide. So N is equal to 647.77, and then also temperature to Kelvin, so we did that, so 299.82, and V is then we can calculate the V. So V is equal to nRT by P. So here N is this mole, R is already we calculate 62.3637 liter mmHg mole Kelvin, 299.82 and by 750 mmHg. So we don't have to convert pressure and other things. So here we directly get that volume is equal to 15959.23 liter. Now if we derive using derived value R, so we can get that 159.59.23 liter. That is the volume. And if we convert that 1 liter is equal to this much of feet cube, so V will be 563.93, slightly different, but we can do that way also. So using derive R value, we get that volume is 563.93 feet cube. That's it. Thank you.